final example that I want to review is what's called a combination. So this is where we are going to stop considering order, formally stop considering order. That's called a combination. And combinations are really good for things like solving what's your probability of winning the lottery. The lottery is one of my favorite things to talk about in statistics because it's a little counterintuitive. A lottery, so a typical lottery, here's one type of lottery. One of the common lotteries works by you pick 6 numbers from 1 to 49. So you can imagine you've got a little punch card and it has all the numbers from 1 to 49 and you get to punch any 6 of them. So there is no replacement here. You can't pick the same number twice. So you're picking 6 numbers from 1 to 49 without replacement. And order doesn't matter. It doesn't matter if you pick them in a particular order. You want to get the right set of 6. You want to match the set of 6 that the lottery authorities get. So what's your probability of winning that particular lottery? So for the numerator, we're going to say, how many ways can you win? Well, there's only one way you can win. You have to match all 6 numbers. So there's only one way you can win. In the denominator, we have to count out how many different sets of 6 numbers can you get when you're considering the integers from 1 to 49. And it feels like, most people feel sort of intuitively like, well, there's 49 numbers, 1 to 49, and you get to pick 6 of them. You kind of feel like you're covering a lot of this space, right? 6 out of 49 doesn't seem that small. You're picking 6 numbers out of 49. But in fact, how many combinations, how many sets of 6 numbers are possible here? The answer is rather surprising. In order to be able to calculate that answer, we actually need to know something called the combinations formula. If you want to know more about where this formula comes from and you want to see the derivation of this, you're going to have to watch the optional module that goes into that detail. But there's a function out there called the choosing function. And what the choosing function does is it says if you've got a situation where you have a set of n objects and you want to say how many different possible sets of r of them can you form, that is a choosing function. It's n choose r, and we write it with this parentheses with the n, the total set on the top, and the r, the smaller set on the bottom. So if I have r objects taken from a set of n objects without replacement and ignoring order, this is a combination. And if I want to know how many different samples, how many different sets are possible, that's an n choose r function. And if you have an n choose r function, it's just a mathematical function, so what you do is you apply this formula. It's n factorial divided by n minus r factorial times r factorial. So that answers the question. If I've got 49 numbers to choose from, and I want to say how many different sets of 6 numbers I can draw from within those 49 numbers, I can just apply the choosing function. So this will work for solving this lottery question. And it works generally anytime I've got this same situation. N choose R. So let's actually apply it to the lottery question. So this is a 49 choose 6 function. How many different combinations of 6 numbers can be formed from those 49 integers? It's a 49 choose 6. So I just apply the combinations formula, 49 factorial divided by 49 minus 6, or 43 factorial, then divided by 6 factorial. And we can just do out the factorials here. We can do out the numbers, and surprisingly, it turns out that 49 choose 6 is almost 14 million. In other words, there are almost 14 million different sets of 6 numbers that you can derive from just the 49 integers. There's 14 million different combinations that could come out in the lottery. So of course that means that your probability of winning the lottery is 1 out of almost 14 million. This is a good argument for not bothering to play the lottery. We're going to talk more about the lottery as well next week. But your probability is really, really surprisingly small. I'm actually very happy that the probability, my probability of winning the lottery is extremely small like this. My philosophy on it is I'm glad there are really great things in life that are attached to a very, very, very small probability, because it turns out there are also some really horrible things in life that are also attached to extremely, extremely small probabilities. For example, your probability of dying in a commercial airline crash is about 1 in 14 million as well. So I'm really extremely glad that I'm not going to win the lottery, because that's the only reason that I can be confident enough to get on an airplane, is that I know I'm very confident I'm not going to win the lottery, so then I can be confident that my airplane is not going to crash. So I'm glad for very, very, very small probabilities like this.